You think holding your breath underwater is a stunt, something trained athletes and reckless daredevils do for a camera. It isn't. It's one of the oldest jobs your species ever had, and your body is still quietly built to do it. Right now, without you knowing, there is a switch hidden behind your face that fires the instant it touches water, a leftover handed down from an ancestor who dropped into the dark for a living. Most people go their whole lives never knowing it's there. So picture the very first one. A human wades into cold, dark water, fills their lungs, and pushes down toward the shellfish glinting on the seabed. No tank, no rope, just one breath standing between them and drowning for a single meal. We don't know exactly when this first happened, but on the coast of South Africa, at a place called Klasies River Mouth, there are heaps of discarded shells dating back around 127,000 years. It's the oldest hard proof we have that humans were already working the shoreline this far back, going under for food. That first diver was not a superhuman. And the most important thing their body did that day, it did without being asked, and it is still doing it right now behind your own face. The instant a human face touches water, something fires. A nerve in the face, the trigeminal, signals the brainstem, and the heart quietly slows by 10 to 25%. No decision, no training. This is the mammalian diving reflex, and every person alive is born with it. That ancient forager didn't switch it on. Their body already had it running, and so does yours. Whatever let them live off the deep is not lost history in a museum case. It is a piece of equipment sitting behind your face at this exact second. And in the one human being where this reflex runs at full, undimmed strength, it isn't the trained diver, it's the newborn. Lower a newborn's face into water, and the response is startling. The heart slows sharply. The baby holds its breath, all on its own. The dive reflex is strongest right at birth, then fades over the first 4 to 6 months. We arrive with the machine fully switched on. Then we let it go quiet. It's an inheritance you grow out of, not into. Whatever your ancestors were doing down in that water, your body was ready for it before you could even walk. That slowing heart is only the trigger. Go deeper, and the body starts physically rebuilding itself under the pressure. Descend far enough, and the water pressure should crush your lungs flat, so the body floods them from the inside. Blood pools into the chest to fill the shrinking space. At 70 meters, roughly 980 milliliters of it shifts into the thorax, an internal shock absorber that keeps the lungs from collapsing. It happens automatically, invisibly, without a single instruction from you. Your body armors its own softest organ against the deep long before you'd ever notice the danger. And while that's happening, an organ most people are told is useless is quietly dosing you with extra oxygen. Hold your breath, and your spleen contracts. It squeezes up to half of its densely packed store of red blood cells straight into your bloodstream, a self-administered mini blood transfusion that buys several extra minutes of oxygen. The organ people joke about as pointless turns out to be a hidden oxygen tank, and it fires the moment you go under. You are not equipped to hold your breath. You are equipped to dive. And that exact trick, a spleen dumping stored blood on a single breath, is not uniquely human. You share it with the animals built for the deep. Deep diving seals survive the ocean the same way. They hoard thick, high-count blood in an oversized spleen, then dump it into circulation on a dive, while the heart slows hard on the way down. A Weddell seal rides that hardware past 900 meters and stays under for well over an hour. What lets an animal genuinely live in the sea is not some alien organ, it's a scaled-up copy of the machinery sitting inside your own chest right now. Push that same hardware to its absolute ceiling, and the numbers stop sounding like biology at all. The Cuvier's beaked whale holds the mammal record on both counts. One dive measured 2,992 meters straight down. Another lasted 222 minutes, 3 hours and 42 minutes on a single breath. It's the same breath-hold body plan you're carrying, just scaled to a limit that reads more like a submarine than an animal. The gap between you and the record holder is a matter of degree, not of kind, and it isn't only mammals in this club. A bird outdives every human freediver who has ever lived. The emperor penguin drops to 564 meters and stays under for 32 minutes, deeper and longer than any human on a single breath. Once you start counting, breath-hold diving turns out to be an ordinary animal profession practiced right across the tree of life. The strange part was never that animals do it. The strange part is that we're on the list at all, wearing the same equipment, just quieter. And we are not the only kind of human on that list. Another whole species was already diving 90,000 years ago. At Grotta dei Mascarini in Italy, Neanderthals shaped 171 clamshells into tools about 90,000 years ago. Roughly a quarter of them were collected alive, prized straight off the seafloor by hand, which means Neanderthals were freediving. It wasn't only our line of humans dropping under the surface for what they needed. A whole other kind of human had already made the deep part of the working day, and the cold water didn't just feed them, it left a permanent mark carved into their skulls. Years of cold water diving trigger bony growths inside the ear canal. Doctors call it surfer's ear. In one study of 77 ancient ears, 56.5% of the Neanderthal skulls carried it, a skeletal fingerprint of a life spent going underwater, still legible on the bone tens of thousands of years later. Their habit is quite literally engraved into their heads. The water didn't just employ them, it reshaped them, and that same engraving turns up again on the exact opposite side of the planet. Pre-Columbian skulls from Panama show the identical surfer's ear growths, tied to long lineages of pearl divers working the Pacific coast. Different continent, different millennium, the same scar on the same bone. Wherever humans made a living underwater, the water reached in and reshaped their skulls the same exact way, as if it were signing its work. And that way of life never actually ended. In one corner of the world, you can still film it happening. Off the coast of Japan, the ama, women freedivers, have gathered shellfish and pearls for well over 1,000 years. They go under again and again on a single breath through a full working day with almost no gear. This is not extinct history behind museum glass. The opening scene of this whole story, a person filling their lungs and dropping into the cold for food, is a job somebody clocked into this morning. But making a living underwater has always carried a brutal, oddly specific price. In the Persian Gulf, pearl divers dropped about 7 meters with a stone roped to one leg and a nose clip of wood or bone. They were expected to make 8 or more dives every 15 minutes, from sunrise to sunset. After the very first dive of the season, their noses bled. This was never a sport or a thrill. It was a human body deliberately worn down day after day for a handful of shells. Some people, though, didn't just endure the deep and climb back out, they moved in. The Bajau, the sea nomads of Southeast Asia, freedive to around 30 meters, some reportedly close to 70, with wooden goggles and a handmade spear. They spend roughly 60% of a 5-hour working day underwater, walking along the seafloor as casually as you'd cross a street. They don't visit the deep and hurry back. They live down there. It's the most direct proof there is that a human body can treat the ocean floor as home. And living there, century after century, did something nobody expected. It rewrote their DNA. Natural selection gave the Bajau spleens about 50% larger than their land-dwelling neighbors through a variant of a single gene, PDE10A, a bigger reservoir of oxygen-rich blood, enough to raise available oxygen by up to 10%. It's the first genetic adaptation to diving ever tracked in humans. Evolution caught red-handed, mid-build, making a better diver. The dive reflex you were born with is the same thread. The Bajau simply had it turned up. At the far modern edge, other people are still pushing that inherited body until it breaks. Trained on nothing but that inherited reflex, one freediver held his breath for 11 minutes and 35 seconds. Another descended past 253 meters, a dive that left him seriously injured. The ceiling of the ordinary human dive response is astonishing. And the price of reaching for it is exactly as brutal as it was for those Gulf divers with stones roped to their legs. The equipment is ancient, the consequences of maxing it out never changed, and yet the oldest, truest version of this whole life is quietly disappearing. Japan's ama have collapsed from more than 10,000 divers to fewer than 2,000, most of them around 70 years old. On Korea's Jeju Island, the Haenyeo, honored by UNESCO in 2006, have fallen from over 20,000 in the 60s to under 4,000 today. Roughly 90% of them are over 60. A way of living that held on for 100,000 years is closing out inside a single human lifetime, on both coasts at once. So the reflex is about to outlive the job that carved it into us. You will almost certainly never dive for your dinner. But you are still carrying the diver, the heart that slows when your face meets cold water, the blood that floods your chest under pressure, the spleen that quietly doses you with oxygen. None of it was built for a swimming pool. It was built for 100,000 years of dropping into dark water on one breath, for food, because there was no other choice. The job is ending. The body it made is still here, folded up behind your face, waiting for a deep it will probably never be asked to enter.